Hey friends, welcome to the first project. Today we're diving into a dataset that I picked from DataCamp. I don't know if you heard of this website, but it's like mainly a website where you can learn how to code, and especially for data science, in the field of data science, it's a very useful platform. So I'm actually a premium member of DataCamp, and I will be developing a project, which is one of the projects in this platform, and all the data sets. Of course, I also are grabbing them from DataCamp itself. In the project, there is the data sets set. I mean the group of data sets that we're going to work with, which are basically 4 data sets, and which later will be take a look at them. And then also the questions that conform the project, I also got them from DataCamp. And actually, you can also see the solutions are also in DataCamp. So that was very cool because I could compare my solutions and my answers with the answers of what's in DataCamp. So I can be sure that the solution and the answers are correct because I could compare it. Now, the level that you're going to need to follow up the project and be able to handle it and maybe reach a solution. It's a basic understanding of the Pandas module of Python. And if you think you don't have yet this basic understanding of Pandas, a very good resource, and that is also free, that you can watch and practice to reach this level. It's the playlist of Code Basics, which I actually watch, and it's really good. And I would suggest you to watch the first 9 videos, and with that you will be able to, you will have this basic understanding of Pandas to be able to solve this project. And so the other thing that you are going to need is to have a basic understanding as well of the matplotlib module of Python. And also, I would suggest you to, if you think you don't have this level yet, I would suggest you to watch the Code Basics playlist of matplotlib, which are 7 videos, and I also watch this playlist, and it's really good explained. And with that, you will have the basic understanding of matplotlib to follow up this project. And basically, the group of datasets, there are 4 datasets, and all these datasets you will be able to find them in my GitHub profile. So you don't have to do anything weird, or so it's gonna be like really easy. Like all the resources are just in this link, and that's gonna be it. And then the other thing you will also need to develop and attempt this project is you will have to probably download the Anaconda distributor of Python, which is going to basically set you up all the data science modules of Python in your computer. And so you don't have to bother searching for all the different packages and different models and downloading it by yourself, because once you download the Anaconda distributor, everything will be set you up for you, so you can you will have all the packages available, and it's just really easy. And I will also show it when I share my screen how you can do it, but it's extremely easy. Shouldn't take you more than 5 minutes. And then with the Anaconda distributor, you will have the Jupyter notebook, which is where we are going to write all our code and show all the analytics and all that. And that is also one of the things that come with the Anaconda distributor. So if you just download the Anaconda distributor, you will have everything, all the packages, and the Jupyter notebook, which we will be using. All right, guys, let's start with this little project here. And let's see. Okay. So basically, all you need to start this project with me
it's this link, okay, because this is my profile in GitHub, and here you will be able to find all the files that I'm going to be using in this project. Don't this file doesn't matter, but the other files, like these 4 files, we are going to be using them for the project. And also, so the other thing that you're going to need for this project, it's the Anaconda distributor, which is a distributor in Python, which basically is going to set you up all the data science models that you are going to need for following in this project and the next project that I'm going to be doing as well. And so it's very easy. You just have to download it here, and then this is going to take you, like, once it's downloaded, to this kind of this page, this application, and you just have to launch in this Jupyter Notebook. You launch it, which then is going to open you like a terminal here, which is in fact going to open this this notebook, which is hosting through the web. All right. And okay, so I think we have everything we need. Okay, so I have here my Jupyter notebook. I'm just going to be creating a new notebook. You just have to go to new, then Python 3. Okay, so here we are ready to start coding and start doing the project. So let's first check on the questions. Let me see, where are the questions. Here, there are the questions. Okay, so first question, well, I'm just gonna take it, guys. I'm just gonna put it like this, you know, because so we have everything in one place. Oh, I hate this about Jupyter Notebook, that sometimes it's difficult with the space. So one recommendation is just make a lot of space when you're going to put something. But okay. All right, guys, let's start. So first question: print the highest weekly sales for each department in the Walmart data frame. Limit your answers to the top 5 departments in descending order. Okay. First of all, I would suggest that we should explore this data frame, Walmart data frame. So we will take it from the GitHub, my GitHub profile. And before, I'm just gonna be importing some pandas. As pd import numpy as np, and we are going to be using matplotlib as well. So import matplotlib.pyplot. Pyplot is kind of like the submodel, which is like an interface of matplotlib, and this is where we're going to be creating all of our figures and axes and all that to visualize our data, which is being asked here. As PLT, all these are the alias that we are calling for each of our Python modules. And so I'm just gonna execute this and go to the next cell. I'm just gonna create a bunch of cells here. All right, I'm actually going to take this and put it here. Okay, so the first thing we're going to do is okay, go here. Oh, okay, was this really the first question? Huh, that's weird. I thought it was another one. Oh, it's the second one. Yeah. So guys, this question, I mean, all of them are kind of they're like not very complicated, but the way we have to import this data for the avocado data frame, it's a little bit weird because it's a pickle file, which is, I think, is not that common, or at least not as common as a CSV or I don't know, any other kind of formats really. So we will see how to do this, but the command is really easy with pandas, but I didn't figure it out, like, I think after half an hour or something like that. Okay, so what I'm going to be doing is I'm just gonna open I believe the data frame for Walmart is this sales subset, if I'm correct. Let me just check, guys, here. Okay, so the data frame for Walmart is the sales subset. Sorry that the name is not very obvious for what is being asked here, but this is the data frame that it has to be used. Okay, so what I'm gonna do is I'm just gonna open this file, and what I'm gonna do is just press here in raw. We don't have to download absolutely anything. We just have to get this link, this direction, and we're just gonna do a data frame for Walmart equals PD. So we're calling the Pandas module, and then we go for the method for reading as CSV, simple CSV. We're gonna be pasting this, and that's gonna be pretty much it. Now I just execute this cell, and if we go and check the data frame of Walmart and check the first 10 rows, and we see that we have the data frame. It's a little bit ugly, guys. I really don't like this unnamed equals 0 thing. Actually, now I remember that when I solved this project, I dropped this column because I just hate it too much to see it here. But it's not a problem really to have it here, so we can just leave it here. Or actually, you know what? I'm just gonna delete it because I really don't like it. I just delete this data frame Walmart. This is like when I imported the CSV file, it's like it already had indexes, you know. So I believe it just took this as if it was like a column, when it's not like a real column. It's just like the indexes, which now it's created again here, and that's why we see the 0, 1, 2, 3, 4. So that's why, like, this is not really serving any purpose, this column. So I just really want to drop this. So we're gonna do df Walmart dot drop and we are gonna say columns equal to whatever this is, which is like this, and see what happens now. Let me see the head of this thing. Oh, it's already done, but whatever. Okay, so we see that we have the same data frame as before. It hasn't dropped the columns, the column that I wanted to drop. The solution for this is just to do it this way, like so it is actually stored in the data frame, although now I'm messing it up a little bit. It shouldn't be here. I know what I'm doing. It should be here. and we run this, and now we can run this, and we will see that now it has actually executed this method for dropping a specific column. If I wanted to drop or eliminate more columns, I had to just pass a list and put all the labels of the strings that are the names of the columns, and that would work. Okay, but I just wanted to drop that column, and that's it. Okay, so we have the weekly sales in here. These are the weekly sales. Okay, and it says for each department. So I'm guessing that I'm just wondering now, like, how many departments do we have? And by the way, this data set, there's no I believe there's no missing values or anything like that, but we can take a look by doing df Walmart. I'm going for description, or I just want to see information about this data set. So this is actually going to give us some information about like the name of the columns, and something I really like to see here, it's the count of non-null values. Okay, and we see that all the values for each column are all non-nulls, because we have 10,774 records, and is the same number for each and one of these, and this is like the number of non-nulls. So we don't have missing values in this data frame, so that's good news. I believe there wasn't not any missing value in any of the data frames, so we are not going to have any problems with that. But I think it's a good practice to check always if we are having like missing values or stuff like that, because that can really screw our later analysis about what is being asked. So what I propose to solve this is that we group this for each department and then we take the maximum. We take the maximum for of the weekly sales for each department, and then we order them in a kind of like a descending order. So we will see the top 5 of the weekly sales for the different departments. All right. So first, I'm just curious. I want to see the kind of like all the unique values of this department column, just to see like how many groupings we would be doing for our later analysis. And so what I'll do is df Walmart dot department. And that's how we're going to select out of all these, like out of the data frame, we are selecting only this column. Okay, so we select the column and we say unique, and this should give us an array with the unique values. So we see we have a lot of the different departments. Okay, so our grouping is going to be somewhat big. Okay, but there's no problem. I just was curious about how many like different departments there are in this data frame. Now we can proceed to do the analysis. And what we're going to do is because this, now I don't want to go up always to see the data frame. I want to have my data frame here, so I'm going to print again, I don't know, maybe 5 records. Okay, and so I'm gonna do this right now. We are going to be grouping it df Walmart dot, we are going to be taking the departments, group by departments, group by department. And now there are actually two ways to do the aggregation. Like right now, okay, so right now if I return this is a data frame group by. Okay, so this is it's creating kind of like a group for each of these for each unique value of this column, and it's gonna take all of the records that have same department. Okay, so of course now to have a result and to convert this into an actual data frame, final data frame, what we do, of course, we have to aggregate this. And so there are two ways to do this, and I think the easiest way is to just take it like this. We are going to put here like the column name of the column that we want to aggregate, which is the weekly sales. Okay, and here's like the method that we're going to be using, which is the maximum, because we want to get the maximum values out of all the different weekly sales for each department. Okay, so if we see what happens with this is what we get. These are the maximum values. But actually I really don't like too much this way of doing it. I prefer, and I don't really know why, but I just really like doing it this way, which is aggregating it by passing on a dictionary. And in the dictionary, first we're going to type the key, and of course the key, and the key is going to be equal to the column label, to the name of the column. Okay, which is going to be, of course, the weekly sales, and we're going to specify here the method, the aggregation method that we are using for aggregating this each of these groups. Okay, which, as we know, is the maximum. And what I like about these guys is that here we'll also have like the name of the column here. You see that right now there's no name here, but if we do it this way, it's gonna be the same, but at the same time we will have this weekly sales establishing here. Okay, so we will have it like this way, which I like it a little bit more. Okay, we see that department is like an index, and the only column that we have here is the weekly sales. If we want to turn off the index, or we want to just make department another column, we can definitely do that with an argument that we can introduce here, but I don't have a problem really for having the department as an index, so I'm just gonna leave it like that. And something else we want to do in order to get the top 5, it's we want to sort these values. Okay, sort the values by the weekly sales, and we establish an ascending equal false, and this means that we are having a descending order. Okay, and so because it's going to be descending, the top 5, the first 5 records, that's going to be our top 5, you know, and we will have our results. So we see we are having, this is the top 5 that we are having, guys. And let's see if there was something else. Bring the highest weekly sales for each department. Limit your results to the top 5%. So yeah, if we just want to limit the results for the top 5, what we can do is just call the head 5, and then we got it, guys. Now let's go ahead and try to solve the next task, which is what was the total of this, I guess it's like the name of a column of organic avocados in 2017 in the avocado data frame. Okay, I'm just gonna take this question and I'm just going to paste it here. This is the question 2, and let's see what happens. Okay, so let's go ahead and get this data frame. Okay, I'm gonna go out from here, and in this case our file, as I was saying, it's in this pickle extension, so it's not gonna be as straightforward, but it's gonna be pretty straightforward, just not as much as this kind of files, guys. Okay, so let's just go ahead and okay, yeah, because we cannot, I believe we cannot see the raw in the GitHub page, you know, so that's why it's not as straightforward. But what's gonna happen is that this is going to download it. You can also download it here, and I'm just going to take this, where is it? I'm just going to this folder. I'm gonna paste it in my directory. Okay, and what I'm gonna do is basically just copy the direction. If you have a Mac, you can just do it this way, but I believe you have to enable this thing. Okay, it's not as I believe it doesn't come like this by default, the computer. So but it's pretty easy. I just watched a YouTube tutorial, and it was pretty, right now I don't quite remember how was it, but it was like some trick around here, but it was a pretty easy thing to do. Okay, so we have our directory, the address of our directory in my computer once I downloaded this, and now I just go ahead and we do something like this. The data frame, I'm just gonna call it avocado. Okay, and avocado is gonna be equal to pandas.read CSV. It's not a CSV, it's actually, the file is like this. Let me just be sure of that. It's a read pickle. No, so yeah, it's like this. This is the actual thing. Okay, and here we are just going to do like R, which stands for read. We open the quotation strings to write a string, which is going to be our address, our direction from our directory. This is the way that we have to do it. pd.readPickle, this is the method. Then we write the R for read and the address that we have our file. Okay, and just execute this, and now we should have our data frame avocado.head. Let's see what happens. Yes, we have our data frame here. Perfect. And so we see that this is the MB sold, which is let me just check what's the data type of this MB sold, which we can do by doing data frame dot MB sold. It's gonna tell us oh my god. I'm just so used to call everything just df. Okay. Sorry, yeah, this is a series. What we want is to index, to get a specific element, a specific value of this column, to see if it is actually like if it's like a number of what kind of thing it is. So because if we later have to aggregate this and we want it to be like a numeric type, so I just want to make sure, yes, it is a numpy floats 64. This is like a numeric form, which coming from the numpy module, which is actually where Pandas is based. Pandas was built in NumPy. So if you see NumPy, there's absolutely no problem. Okay. And what we want is the total MB sold. So we want to aggregate all this by a sum. We want to sum all of this. And we want to do it for the avocados that are organic, which I'm guessing that the organic it's within the type column, but we can find out here. Avocado dot type dot unique, and this is going to give us the unique values. And yeah, guys, we see this is the organic is in this column. Okay, it's existing in this column, and there's actually only two unique values. It's conventional and organic. Okay, so we see that, as I see, is we will have to filter by this organic. Okay, so we'll just get records that in which we have that organic is true. We have the first column that we want to filter. Okay, and what's the other column in 2017? Okay, oh, actually this is like this data frame. It's not very complicated. I mean, they even put us like the year here, so it's so like easy. What I'm thinking that I want to create is kind of like this Boolean condition, which takes in which filters by these two columns, you know, the type and the year. So we can create a Boolean condition, which is going to be equal to it has to comply one thing and it has to comply another thing. So one thing that it has to comply is that the avocado at type, or actually I'm just gonna do it like this, type has to be equal to organic, and avocado at year. So this is just another way to take a column. Okay, we can do it this way, or we can simply do it this way. We have both ways to do it. Okay, and I just use it really exchangeable. I don't think it too much, and just use the first one that comes to my mind, like naturally. I don't know. But right now, let's just leave it like this. So we can say this is equal to the year 2017. So that way, you know, we are creating what this is going to be is it's going to be like an array, okay, of trues and falses, and these trues and falses are going to come from, of course, this condition. So it's going to go here, for instance, to the first row, and it's going to check that it's not complying with this condition and it's not complying with this condition, so it's going to return a false. Okay, and even if this would have been organic, even in that scenario, this still has to be 2017 in order for this to work out, because this is what I'm establishing an AND operator, so this and this has to comply. Okay, another way would have been to do the OR, but in this case is like any of these conditions. If it complies any of these conditions, it's going to return a true, but this is not the case right now. We are using an AND operator, so both conditions has to be true, met true, so that it's going to return a true and store it in this variable Boolean. Boolean is too serious name, I think. I'm just gonna call it avocado bool. I don't know. Okay, and all right, guys. So we have our conditional here. Sorry, we have our Boolean expression here, which we are going to pass to this data frame to filter for the records that we want. And so we are going to say data for avocado organic 2017, it's equal to avocado filter with this thing right here. Let's see. I think the problem here is that apparently all of these are falses, and that is because these are not stored as strings. You know, if we see type of avocado dot year, we will see, we will see that this is a number. Okay, so this should be a number as well if we want this to work out, because otherwise it's not gonna find the 2017 any of these things, because the data type is completely different. So we really have to be careful with that, guys. Now, so I'm gonna execute it again. I'm gonna execute this. Okay, so basically the problem was that apparently we have to put here the parentheses. I was missing on that thing, so it should be a tuple actually, and now it should work out. Now let's see the avocado org 2017 head. We can see, guys, we have the organic and the 2017. So now we can go ahead, of course, and do the aggregation. It can be sold, and we are going to sum all of this thing, and this would be the solution for exercise number 2. Let's go ahead and try to solve now the third question. Just create a bar plot of the total number of homeless people by region in the homelessness data frame. Order the bars in descending order. Bonus, create a horizontal bar chart. Okay, so we can create a horizontal bar chart. So yeah, we can, I guess, with this data frame we can group by the region information. Then of course we can sum the total number of homeless people for each region, and then we can create this horizontal bar chart. Okay, so let's go ahead and first I want to have this here, so I'm just gonna do this like that. I don't know if this is really useful actually, but okay, yeah. Okay, question 3. And okay, so we are going to come here to my GitHub profile, and I'm going to search for the homelessness CSV. We get it from raw. Now we're just gonna take this link, and we're gonna do it, and we're gonna create our homelessness data frame. This is gonna be equal to pd.read CSV because it's a CSV file, and we are going to just paste this and execute it. And now our homelessness data frame should be working. Yes, we still have this column that I really don't like, but we are just gonna leave it there. Okay, and now it's not bothering me as much. I don't know. Okay, let's just put a bunch of cells here. Okay, and so what I want to do is, okay, maybe I can check a little bit of information about this data frame. We see how we have 51 entries. This is 51 records, 51 rows, and we don't have any null or missing values. So we have all the information that we need. I mean, we don't have to be cleaning up anything here. Everything looks pretty good. Okay. So now what I would propose to do is take this data frame, and we're going to apply the group by method, and we're just going to group it by region, and then we're going to aggregate this. We're going to aggregate region state, the individuals. So these are the homeless and number of people, and we introduce here like if it was like a dictionary or something like that. I mean, it's a dictionary, but it's a weird dictionary. Okay, so in the key of the dictionary we have the column label, and in the value of the dictionary we're going to have the aggregation method. In this case is going to be, we're going to use the sum, of course. It's going to sum all the individuals, and we are going to save this in homeless per region, something like that. And now if we see this, execute this, we can see how we have the number of individuals, the number of homeless people per region, which is what we wanted. Now we want to create a horizontal bar plot. For that, what we're going to do is we are going to call the PLT module, which is the submodule of Matplotlib, and we're just gonna do bar horizontal, and we're going to introduce the Rx, which is going to be this thing, but kind of like the individuals. Sorry, the X. Okay, so the X, it should be the region. X should be the region, yes. So this should be, and because this is an index, this is not a column, guys. Okay, so I cannot say here like region. This is going to give me a mistake. It's not gonna take this thing. And in order to call these, we need to type here that this is the index, because this is the index of this data frame of only one column. Okay, so we have to call it like this, index, and now it's gonna take this. Okay, and for my following value, we're gonna have these individuals, which is going to be like individuals, like this, individuals. Okay, and let's see what happens if I just put here the show command. Okay, nice, we don't have any mistake. And also one thing we can do is that we can actually I'm thinking that I can sort this, sort the values, and we're going to have our individuals, because we want to sort it by the individuals, and then establish the ascending equal true. I'll see here, I'll see like this. It's a little bit weird that I would put the ascending true, because we want to see like the top, but for the bar plot it's kind of weird. Okay, and sometimes you have to play with this, like put it like true, false, whatever, until we have the outcome that we actually want. I just remember that I had to put the true because at the beginning I was always putting in false, and I didn't like the shape of my bar plot. So now I learned the lesson and always put it like this, true, if we want to kind of like see the top measurements in the above part of the graph. And so here we have our bar plot, guys. This would be the solution for this particular question. I'm just checking that everything is okay. Yeah, it looks okay. One thing I wanted to show you guys, which I think is pretty cool, and I use this all the time, is that we can come to these websites and we can actually see a lot of different palettes and different colors that we might want for our graphs, and I just have so much fun with these guys. I really love it. So I would just go here and just explore different palettes and different colors until I see one that I really like. For instance, what I'm liking right now, I really like this color, so I'm just gonna take it. Like when you click on it, it's already copied, so you don't have to do anything else. And then when you come here, you can just specify that the color is equal to, and now the only thing that you have to do is type a hashtag so that it understands that it's like a color code, and then you will paste what you copied in here. And now if I execute this, it should change the color to the color we selected from that website, and this would be the result, which is, I think it's really beautiful. And I think also it would be nice if we specify here in the x-axis that these are the individuals, the number of homeless individuals. So what I can do is we can go plt.y label, sorry, x label, and we can just type here number of homeless people, and that should appear in here like this. Perfect, guys. And now I think we can go to the fourth question, which is create a line plot with 2 lines representing the temperatures in Toronto and run. Make sure to properly label your plots. Bonus, add a legend for the 2 lines. Yes, that is what I was thinking. And okay, so just like before, I'm going to do it this way. I'm going to put here like question 4. I'm just gonna create here a bunch of cells. Okay, and so first I'm gonna import the dataset. For that, I'm just gonna come here to our temperatures, CSV, perfect. We're gonna to row. It's just gonna copy this, and now it's like temperatures. It's equal to this is the name of, it's gonna be the name of my data frame. This is gonna be equal to pd.read CSV. Here I'm gonna paste my dataset, my direction. So now if I just come here and call the head, okay, we see we have actually our dataset here. Okay, so let's go ahead and let's see what we can do here. What I would propose it's to create a individual data frame for our Rome city and the Toronto city. So two separated data frames. And then with each of these data frames, we can then plot them in the same graph. And then we can label them, and I think that's what I would do to answer this question. So let's create our first data frame, which it would be like this. So is the temperature, let's call it temperature Rome. So we can say that this new data frame is going to be the entire data frame and filter for the city of Rome. Okay. And so I should have everything, but only for the city that is equal to Rome. So just for the Rome city. Okay, so let's go ahead and do like this temp data frame, where the temp and this is like right now I'm just trying to get this city like this. It's equal to Rome. And by the way, now I'm just curious how is Rome written in this column. So I don't know if maybe it has like a like it's not capitalized, so it's like a lowercase letter. So I want to check that out so that I don't have problems when I'm filtering the data set. So what I can do here is actually temp dot city, so that we are only selecting this column. So right now we have this series or this column here. Series and column is basically the same thing in Pandas Module. And we are going to what are we going to do? So we are going to get the unique values. And so we can see where Rome stands. This is in alphabetical order, so it's very easy to spot what we're looking for. And we had it like this is Rome. So this should be okay because it's like it's the same it's the same letters and it's the same capitalization and everything. So we can go ahead now and yeah, this should create our data set here. Now if we actually go ahead and maybe look at some rows of our new data set, we are going to see that we only have the Rome city. So that's great. So we have the Rome part covered. Now let's do exactly the same thing for Toronto. And we are gonna call this temp Toronto here. Say temp Toronto. Okay. Let's go with this. Okay. Which is being created and it's working fine. Also, we can see that Toronto, it's here and it's exactly the same as here. So there's no problem with that as well. And now we can go ahead and start plotting our data frames. I mean, we're only gonna be plotting the average temperature, I guess, because we have to make the plot of the temperature, representing the temperatures in Toronto and Rome. Yeah, so we're going to plot the average temperature for each city and for each of these both cities along with the date. Okay, and now I'm curious as well about what is the data type of the values of this date column. If these are actually like timestamps or date time type of data, or if these are like strings, because I think that's gonna make a difference when we do the plotting. So let's go ahead and just see, for instance, if we grab this one, or yeah, let's just grab this one. I guess this one should work fine. And we go to take the date, and we say that we want just to grab a random element, and let's just say that we want it in this index and see what happens. Okay, so we see this is a string, guys, and I really would like to have this in timestamp. I think it would be better thing to do. So I'm gonna go ahead and just convert this from the string to datetime data type, and this should be fairly easy because I think the format of this string is already pretty straightforward, and so Pandas can detect it very easily and automatically convert it to a datetime. And so what we can do is take, for instance, our temperature Toronto, where we have this date, and we can set this equal to this date. Sorry, we should start by saying pd.to datetime, and now we can put our date here, and this should convert it. So yeah, guys, this happens to me a lot. It suggests me to use the lock, but this still should work. So I think there's there shouldn't be any problem with the execution of this cell. And now let's verify that this is actually a datetime data type by just taking the Toronto date, and we index it maybe at one of these values. We can see, yeah, effectively it's a timestamp now. So I think this is gonna be way better to when we are plotting our columns. And now let's go ahead and do the same for the ROM dataset. So I'm just going to copy this. I'm gonna say that here I want ROM, and it's the same column label because they are both coming from the same data frame, so that's okay. And this should be ROM. Now we execute this. The same thing here. And now let's say that I want just to check the data type. But of course now we should grab one of these index. And by the way, we can easily get rid of these weird index numbers just by saying reset index, just by applying that method. And that easily should take care of this, and it would be reset to this 0, 1, 2, 3, 4. But right now we don't care about changing the index because we just care about this column, and we just care about this column, and we just care about this column, and the same for this data set because we are only going to use those things for our plotting, which is what is asked. Okay, so, but let's say we have this index, just because I just want to check the type. And yeah, effectively, it's a timestamp. Okay, so now both of our date columns in both data frames are timestamp data type, or timestamp or datetime. It's exactly the same. In Pandas, datetime and timestamp is exactly the same. There's absolutely no difference. So yeah, I believe timestamp is how Pandas call this kind of like date, handles this date data. And then for Python, for the general Python, I believe it's datetime. Or maybe it's the opposite. Let me just check it here. Maybe it's the opposite. Timestamp versus, oh, look. I think I already searched for this, I believe, a few weeks ago. Timestamp is the Pandas equivalent of Python's data. So for Python,
it would be datetime, and for pandas, it would be timestamp. So I think that's how I said it. I'm not sure, but anyways, this is the correct statement. Okay, so and that's why it's the equivalent, because pandas just calls timestamp what is a datetime for Python. So they're really exchangeable, at least when we are working in pandas. And so that's why we have here that is a timestamp, because that's how pandas call it. Okay, so that's fine. Now we can go ahead and start plotting. Let's do our plots here. We can do plt.plot, and let's start with ROM. Let's plot ROM. So what I'm gonna do is I'm gonna take this data frame. Okay, and let's take let's take this column here. Okay, so this is what's gonna be in the x-axis. So before this, we should have our date. So in the x-axis we have our date, and the y-axis we will have our average temperature, and so we will see how is the evolution of the temperature along with the dates, with the time. So this is gonna be one plot, and actually I think I can just go ahead now and show it, I believe. So it looks something like this, which now I'm remembering how the solution was, and it was something like, when I saw it at the beginning, I thought like there was, I don't know, something wrong, because like so weird, at least the first time I saw it, like the first instant. But then like I checked the solution and everything, and yeah, it's something like this. I mean, if you really see it carefully, it kind of makes sense, you know. Some days it just changes a lot, right? Because it's, I guess, the seasonality really makes a difference for how's the temperature going. And now we can go ahead and do the same thing for Toronto date, and we have to run to here as well. As you show it, yeah, it's showing both plots, and this is why we need to label them, guys, because we here, if you only see the graph, you cannot know what is wrong, what is Toronto. You just see a bunch of lines here. So we definitely need to label this, and we are going to do it this way. I mean, I think it's the only way you can do it. I mean, the only way I know how to do it, and the most common one. So let's just put the label here. Let's say wrong, and here let's say that this is Toronto. Okay. And another thing that we need is plt.legend, because this plt.legend, that's what's going to activate, that's what's going to like actually create a little box in which we are going to have our label texts. So if we go ahead and do this, we're gonna have it like this here. And there's also a really cool feature in the legend method of plt, which is that we can actually go ahead and try to locate this box in the best position in this graph. So we can do it like best. I think it was something like that. I always confuse. Let's see if this time I get it right. Best. No. It was location equal best, I think. Okay. Apparently this is the best spot that we have. So okay, let's just leave it like that. And then I guess another thing it would be really cool to put here is the plt.y label, so we can actually
the average temperature. Let's just go like this, temperature. So yeah, it should work out, and this is pretty clear that these are dates, so I don't think we should put anything here. I think another thing we can do for the legend is that we can go ahead and change the transparency so that maybe we can see a little bit better these lines. And we can do that, I believe, with the alpha. Alpha, I believe it is, or is not. Okay, still running. I think there's a clear problem here. Alpha, unexpected keyword. Okay, so this doesn't exist. So sometimes what I do, or I would say a lot of times what I usually do is I come here to whatever method I want to analyze, and a really cool feature here in Jupyter Notebook is that you can use the Shift tab, and it's okay, Shift tab, and you can see a bit of documentation about this that specific method that you have selected. And I'm not sure if this is a particular way to do it in a Mac, but anyways, you can figure it out in these options here, so it shouldn't be any problem. And so let's see what's the problem here, because I believe there was an alpha parameter to set a specific transparency. This is what I was saying about the location, best location. Yeah, we can also do all of these ones if we want. Another one that I'm searching for, which is alpha. Let's see what it is. It is. Fuck, there's a lot of things here. Transparency, or maybe if we just search it here. Transparency legend matplotlib. Oh. All right, this looks very nice. It affects both the background and the edge. How can I apply transparency only to the background and not to the edge? I have tried edge color, face color. We can apply it to both of them. I think there's no problem. So I'm just gonna grab this and type it here, maybe. Yeah. Nice. It's definitely way more transparent. So I think it can be really nice. It's very clear, this the lines that are behind the box. So that's great. But what if I set it to like 0.2? Let's see what happens. Maybe it's too clear. That's like too clear. I don't think it really looks too great. I think I like it like this. I would just leave it like this. And something else that we can do here is we can make it bigger. This image, we can make it bigger too, so there's like more clear. And I believe we can do that like just saying plt dot fixed size. I believe it was fixed size. Now let's see some documentation for fixed size. I'm not sure it was fixed size. Oh, let me just search here. PLT fixed size, something like that. How do I change the size of figures drawing in Matplotlib? Yeah, Stack Overflow is a really good one. I always normally go there to check everything that I need, and I can't figure out like the syntax for myself. Kind of like I have an idea of what I want, but I really forget the syntax of a lot of the commands, so I spend a lot of time in this kind of websites, and especially Stack Overflow, which is one I really like, and it has just a lot of people behind. Like we see, for instance, this comment is being voted like 1,000 times, so there's just a lot of people here, and it's a very helpful community. So how do I change the size of a figure chart? Matplotlib figure tells you content from Matplotlib. Import figure. Create an inch by inch image. Figure fixed size. Okay. I think that's gonna work. I think this DPI is kind of like the density per inch, which is just to establish like the quality of the thing. And because I'm not gonna export this image as a PNG or another like extension, I'm not really interested in that argument, so I'm not gonna use it. Just forget about this one. Damn it. Yeah, let's see. 20. Fucking losing my mind here. Let me just maybe if we do it here. Alright, this worked. So we just had to put it at the beginning. Okay, I'm thinking that this is because first kind of like the figure has to be like created, right? Like which is kind of like the container of everything, right? And then you start adding the data, adding the texts, adding the whatever it's within this axis canvas. And so yeah, like it can be kind of like very intuitive, right? Because if we first put the data and then we define the size of our figure, it's like the data already has like a size, I don't know, so probably it's not gonna change if we put it after. But if we put it at the beginning, we're already establishing what is the size of the whole thing, and then the data points are in a certain position across the entire figure. And so yeah, you know guys, this is really cool when you really like try it by yourself always, because it's only when you make the mistake that you will actually learn it. Because I don't know, like I heard this podcast from a neuroscientist. His name is Andrew Huberman, and he was talking about how to learn faster. And the best way to learn and to optimize learning is to make mistakes along the way. The more mistakes you make, actually, the more you're going to learn. And this is because when you make a mistake, it's kind of like your neurochemicals, everything that is in your neurological system, everything kind of like changes, like its configuration changes, all right? And it has to like readapt. And when that happens, there's it's like an openness for your brain plasticity. So your brain plasticity goes up significantly, and the higher the neuroplasticity, and the higher is your rate of absorbing information, and the more retention along time. So if you really want to learn something, you have to try it, and you have to make the mistakes, and even be willing to make the mistakes, you know. And this is also very like, I don't know, like hopeful because you make a mistake and you're normally like frustrated about it, right? You're frustrated because you think, you know, you are like wrong, you're not doing it correctly or whatever, and so you get frustrated, and then you want to give up on what you're doing. But if you can just remember that when you are doing the mistake, it's actually for the better, for your better development, for you to actually learn something faster, And that can really like change your, I don't know, your psychology about that, right? And actually motivate you to keep going, you know, and be like also a psychological support there, right? So you can keep going. So yeah, I always try to remember that. But yeah, guys, I mean, this was everything I had for today. And as I was saying, I took these all these questions from DataCamp. So these questions were here like in DataCamp, and I just like did them first. I compared with their solutions, and I checked that everything was correct, and then, you know, I felt, you know, kind of like confident, I know, that I could teach this.
Now, I also want to say that I'm not data science with an official background in data science or anything like that. I actually just learning data science on my own, and this channel is basically kind of like a recording of this journey as I try to become a data science. And basically most of the videos, what's gonna be is that I'm gonna be making a project, and I'm gonna record myself doing the project, and then I'll just upload it as a video in this channel. And then I will always provide all the tools and resources that you will need to follow along the project, so you can also try the project by yourself. And then if you get stuck, or you also want to watch an alternative way to solve the questions, you can watch how I do it, and you can compare like the ways on how to proceed, and I think that's also a really useful thing. My official background is actually I studied chemical engineering and business management, so it is not very related to data science. Maybe a little bit of statistics and programming I did in my bachelor's degree, but nothing too specific about programming or machine learning. Or I think when I was in college, I didn't even know what machine learning was too much. And one big component for why I started this channel is that I firmly believe that to master something, you have to teach it. Okay, to really learn something very well, it's very important that you teach it. And this is something that Richard Feynman, which is one of the greatest physicists of all time, he always say this, that if you really want to understand something, you have to also teach it. So that's why, you know, I got enthusiastic about you know, solving these projects, which I was going to solve it anyways. And I thought maybe because I don't have anyone to teach, right? And I wasn't sure if I like could even teach, you know, because I'm like not a data science expert. I'm just gonna record videos about me doing these projects with solutions that I'm certain that are correct, that I'm actually getting to the right answers of these projects, and just sharing it with people and see what happens. And I think this really can be useful to people, because, you know, projects is a way in which you actually do something, right? And it's really by doing that you can learn something, you know. So I think this can be, I think and I hope this can be useful to other people. And if you are someone who is in a similar journey as me of becoming a data scientist, or you just want to improve your data skills, maybe these videos will be useful to you, hopefully.